Hello everyone, welcome to Mifratech. Today in this section we'll see one important library or package Dlib, which is very helpful in machine learning and OpenCV, all image processing related applications. So let's discuss. So these are the concepts I am going to cover in this section. First we'll see what is Dlib, and let's see what are the different features of Dlib and what are the applications of Dlib. At last we'll see how to install Dlib. So let's start our discussion with what is Dlib. A Dlib is a important tool kit which is very important in machine learning algorithms, which is also mainly used for like image processing and video processing related applications, and it is written in C++. So it is Dlib is as I told, it's an open source library which allows to use it in many applications free of charge, as you can use it freely, and it is like a design heavily influenced by ideas from design and components based software engineers. As I told, it is mainly like it contains like individual components of software which will be very helpful in face recognition, facial detection, face landmark detection. There are a lot of applications you can use this Dlib library. You can use it in machine learning like neural networks, and you can also use it in OpenCV. It is used for Python related applications, etc. So it is used both in industry and academia, where a wide range of domains. As I told, it is used in robotics, embedded device, mobile phones, in a large high performance computing environments. You can use this Dlib library, and there is a mainly Dlib for facial recognition. We'll use mainly two inbuilt modules like called get underscore frontal face detector. One more is shape predictor. So this frontal face detector mainly used to predict a face from a like you call a image or a webcam. From that you are going to like to detect a face, we are going to use this get frontal face detector. One more is shape predictor, to like to predict the shape of like person shape. In order to find out the landmarks, we are going to use this shape predictor. So these are the two different inbuilt modules we are going to use in facial recognition and face detection applications. So it's, as I told, face is a landmark of a facial detector, that is shape predictor. It is pre-trained. There's those two are pre-trained models which are used to estimate the location of facial points on person's face. Like in a person's face, we are mainly going to locate different facial landmarks like nose, mouth, eyes, nose, eyebrows, person face, like you can call jaw. So different facial landmarks we are going to like detect using these inbuilt modules. And the Dlib's frontal face detector mainly returns an object detector that is recognized by to find human face. As I told, this frontal face detector mainly it will find what it will return. It will return an object detector. That is how it is configured, means it is configured like to find human faces looking like more in a camera. We are going to recognize the human faces. So it mainly it works with the grayscale images only. So before feeding into this algorithm, we have to convert our like video cam image or a normal image to grayscale. So one more, there is a get frontal face detector. As I told, both of them will return a detector, that is function we can use to return faces in information. Like we can get information about human faces, as like landmarks also we can detect. As I told, each face is an object you can consider, like they which contains lot of points where the images can be found. So that object it will return. So this frontal face detect what it will return, it will return an object which like a bounding box where you can find a person's face. That's the main application of this using Dlib's frontal face detector. So what are the different features of Dlib? We'll see. First, you can use for documentation purpose, and it provides high quality portable code. So this libraries you can import in any program, and you can easily use it irrespective of like OS. So it is very like a portable, and it will provide a lot of machine learning algorithms. You can use this and numerical algorithm. This Dlib library provide machine learning algorithms in order to work on image and video, and numerical algorithms and graphical model interface algorithms. It is also used for image processing. So threading, networking, graphical user interfaces application in the GUI applications, you can use this, make use of this Dlib library. And for data compression and integrity algorithms, general utilities. So these are the different features available in Dlib's library. So as I told, one of the important we can find is facial landmarks. So facial landmarks are like used to localize or represent the salient region or facial parts of a person. As I told, you can indicate a different salient features of a person's face, like eyebrows, eyes, jaws, nose, mouth, etc., using this Dlib's facial landmarks detector. And facial landmarks is a technique which can be applied in application, like as I told, you can make use of these facial landmarks as a tool to in applications like face alignment. You can do head force estimation in the applications like face swapping, like blink detection, drowsiness detection. In those all those applications you can make use of this face landmarks of Dlibs. And one of the main aim is to detect facial structure. As I told, from it will detect the from any one person's face. It is going to detect facial structures using this Dlib's shape predictor inbuilt module. So using those like frontal face detector and shape predictor, using those two modules, you are going to detect various feature like facial features from a person's face, and we are going to make use of this in different applications. So the facial landmark detection has mainly two steps, as I told, to detect the key facial structures on person face, like nose, mouth, jaw, ear, eyes, like that. And it also involves the localizing the faces in the image, like it mainly detect those points and localize, like give a set of points where a person's face can be found. So the facial landmark detector, which is, as I told, it is a pre-trained inside Dlib library for Python for detecting landmarks. So it is also used to estimate a location. As I told, there is a shape predictor, which there is an inbuilt data set like 68 point shape predictor data set. So using that folder, we can like read that file using shape predictor. So that mainly contains 68 unique points in a person's face. So those points can be used to locate a different facial features from a person's face. So these index of, as I told, the location of points is nothing but each point is located by xy coordinate, which map to the facial structure. So these indices of 68 coordinates or points what I told are easily visualized on the image below. I will show you how that will be looked. So as you can see, these are the different 68 facial like coordinates or points in a person's face. It starts from 0 to 67, as you can see here. So these different points we are going to read using shape predictor module, and by localizing these different landmarks in a person's face, we can make use of in different applications like face swapping, face alignment, and different filter applications we can use. As you can see, from point, as I told, from point 0 to 60 indicates jaw. Similarly, from 36 to 39 a left eye, from 42 to 47 a right eye. So from 27 is a midpoint between these two. So you can individually also you can use this different in a for loop. You can use set of, like if you want to just to detect eyes means, you can just use a for loop which just localize from point 36 to 41. If you give that number within the range, you can detect left eye. Like that particular part of an image, like a person's face, particular object you can detect, or you can detect a whole face structure, like that. So as I told, the location of the facial parts, like the left eye is accessed from 40 to if you are using index from 42 to 47, you can access the left eye. For 40, from 48 to 67, you can access person's mouth. From left eyebrow to access can be accessed using 26 to 20, 22 to 26. The nose can be accessed using the point 27 to 34. Like that, you can access a right eyebrow from 17 to 30, 21. So these are the different points between 0 to 67 you can make use of to indicate like particular parts from person's face. And the jaw is accessed via 0 to 60. So these are the different ways you can access individual facial features, or you can access the whole, including all the facial features using from all the including all 68 points in your shape predictor. So what are the different applications of this Dlib? Dlib is an advanced machine learning library. As I told, it is mainly used to solve real world complex problems. As you can try, like you can do facial recognition, facial detection. All those are different application used in security purpose, in a different application you can make use of this dlib library, and it is mainly created using C++ programming, but it works with C, C++, Python and Java. You can make use of this dlib library in all these different languages, and it is used in like robotics, embedded mobile phones, large high computing environments. You can make use of this dlib library in those applications. So dlib for face detection and facial landmark detection. As I told, for face detection, facial landmark detection, you can make use of this dlib library. It also contains some of the software components like networking, which are helpful in networking threads, graphical user interfaces, in data structures, for linear algebra, machine learning, like image processing related applications, data mining techniques, text parsing, numerical optimization, for neural networks, and many others. So these are the different like the libraries or different modules you can find out in a daily library or package. So those you can make use of in different applications. So it is both used in both industry and academia. As I told, in different domains we can make use of this dlib library, and implementing a wide variety of, so it mainly we can to implement different machine learning algorithms like classification, regression, clustering, data transformation, structured prediction. In all those applications also you can make use of this dlib library. So as I told, it mainly used in like a dlib plus OpenCV, dlib plus like TensorFlow. So there's different collaboration, like using this dlib and OpenCV you can detect person space, and you can use it in real world application, and you can recognize a particular person and tell his name. So these are different application where you can make use of this dlib library along with OpenCV, TensorFlow, like neural networks, different application you can use this dlib library. As I told, like this, it is going to locate all the facial land features from a person face, and then it is going to like detect the person's face. As I told, like this, you can make use of this library to like detect a particular person's face. As I told, you can only detect eyes, a particular point in an image. That also you can do. Like you can like mainly, as I told, it first like draw a boundary where you can find a person's face, so that boundary can also be drawn. As you can tell, face detection with dlib. This is how you can do. Like for final output, it may look like this. And at last, as I told, these are the different application you can make use of this dlib library. So using this different application, you can also like use this separately, and also you can combine all those application in to make a complex to solve the complex real world problems like security purpose, to detect a particular person's face. In those application also you can make use of dlib library. So at last we'll see how to install this dlib. As I told, uh, uh, this the dlib installation process I will tell you in detail. First, what you have to do is, first you go to a command prompt in your system, then you change your directory in the command prompt. It may be like locating to any other directory. First you change your directory to a location where your Python has been installed. Like example, in my system, in the C drive, in the folder called program files, in one more folder, subfolder Python 36. In that Python you can find this like in your system which version of Python you have stored, that version you found, and there you can find files like this. Inside that Python folder you can find a folder called scripts. So up to that link directory you copy, and you can change this directory in your command prompt. After getting this particular directory, again in command prompt you write like pip install dlib. Just writing this pip install dlib, you can install dlib in your system. If you are getting error using this command, means you can make use of one more option is there, like pip install dlib like minus user. So you can use this command also in order to install dlib in your system. So these are the two different ways you can install dlib in your system. So there is an alternative method. If you are not able to install using those two methods in your system, you can make use of this alternate method. That is, here you just in the same command prompt you just type pip install package, like pip install. Here I mentioned package link. The package link is given below. Here you can see http. So you just copy this whole package link and paste it in the place of package link. So pip install, if you type this link, whole link, and hit enter, you can just install dlib easily in your system. So this is the alternate way. First you just try those two methods as I told, pip install dlib or pip install dlib minus minus user. If you are not able to do it, means you can use this alternative method. So this is how you are going to just import dlib in your system, and while using in a program you just have to write import dlib, and you can make use of the dlib library in order to execute like in order to include in your programs for various applications. So thank you for watching the video. Thank you.